Hi everyone. I I hope that you guys can hear me okay. I'm Justo, and this is the first time that we're doing this, and I think you could see that from the video perspective. It was a complicated task for me to do. We will get it better next time around. I'm sure that Fatima is with us as well as Jorge. Jorge, you're on mute.
Hello, good afternoon, everybody. Excuse me for this first issues of this first live stream that we are doing from Shapelets. Hi, everyone from all the countries that you are watching us this video. Today, we are gonna describe a little part of our product, which is how we manage the ingestion and the queries of data. Justo, our CEO, who is with us, I want to explain us exactly how we are solving these issues, these activities in a minute, in a while. If you have any kind of question, please feel free to send us through LinkedIn or YouTube, and we are gonna answer you at the end of the demo. So, Justo, all of you, and come on with the explanation.
Okay. I promise not to take a lot of your time, and I want to take this opportunity to share with you some of the work that we've been doing in Shapelets over the last. I would say over the last few months, that's for sure, where we've been listening to our customers and reflecting a little bit the way we deal with data in our platform. Shapelets is a platform for data scientists. We want to, and therefore it doesn't exclude you for using your libraries of choice, for your editors in choice, but we're here to help you in the common tasks that you do on a daily basis. And for that, we learn a lot from our customers, from the pain they have, for example, working with medium-sized data sets from the perspective of transforming data, accessing data, just making sure that the data is ready for the analysis that you want to do, no matter where it sits in your organization. So for that purpose, we have rethink a little bit how Shapelets can help you out. And today's presentation is going to focus precisely on data management and how we can access data stored in files. How do we compare with other tools that you probably know and use already, which are great nevertheless, but still we think we can provide you with an improvement in terms of the usability of some of the tasks that you do on a daily basis. So for the first part of the presentation, I'm going to be using Shapelets from Jupyter Notebook. And the first thing that I would love to show you is a little bit the taste Shapelets has. I hope you guys can see this okay. What I'm going to be doing is just increase the font size. Probably you will see it a little bit better. So a typical scenario that we all have played with is the taxis, the New York taxi dataset. For those that you don't know it, it's a very well-known taxi. It's a very well-known dataset that spans for many years. In this case, we have loaded for this demo just a couple of years. So just to give you an idea of the size of the dataset, it's about every single trip the taxi has made in the city of New York and the surrounding areas of New York. And a month of data is more or less about 450 megabytes in terms of size. The Parquet file is about that size. And say, for example, 2009 is a little bit over 5.3 gigabytes in size, right? So if we wanted to just use pandas, for example, for loading this data set, we will end up writing a query like this, just read from Parquet as we always do, just basically pick up present the folder here where the Parquet file happens to be. And now what we're going to do is it's a very simple aggregation. We're going to create a time series here, which is basically group update an hour and just compute the mean of the mean passenger count in this particular case. So if we were to run it, which is happens to be doing it now, then we'll see more or less the time that it takes to load use data. So it's taken about use the time 15 seconds approximately, and basically the results are displayed here on the screen. It's about 744 rows, the ones that are provided, which is fantastic, business as usual. If we do the same thing with a different library, in this case Polars, which is also a very powerful library for data management, which I recommend you to have a peek. As you can see, slightly better in terms of time. It's about 12 seconds on the wall, and the wall time is about 7.5, or more or less the same. So all of this, as you can see, the syntax these libraries provide, well, it changes, but they all have the same feeling in terms of accessing individual columns, providing expressions, and so forth. And basically, you get used to this type of syntax. We've been rethinking a little bit the way we do things in Shapelets. And to be honest, there is something that is really kind of nice in Shapelets. This is the Shapelets API, by the way, whereby, as you can see, we are basically creating a sandbox, and explain that concept in a second. Just loading the Parquet file from exactly the same location as before. And within the sandbox, which I call playground over here, what we can do is actually mix and match any data set that you have in your organization, whether it's CSV file, whether it's Parquet, whether it's pick your poison, really. We are compatible with Arrow as well, so you can, even in those formats that we might not support it, they can be exported to Arrow, then they can be read and can be used by your tool. But the first thing that I would like to point you out is a little bit how the queries work. As you can see, we're using 4 comprehensions here for executing the query. And what we are doing is exactly the same queries as the syntax over there. However, in our opinion, and in the opinion of the users that have been playing with the framework, this language feels far more natural, because what we're doing is basically just importing the functions. And now what we're doing is simply just get the date of the pickup, get the hour of the very same time, and performing an aggregation with the average of the passenger count for every single row in the taxis data set. So what we do internally is basically study this expression. We transform this expression. We actually pass it through a relational calculus engine that give us all the optimizations so we can execute it as fast as possible. And lastly, what we do is we don't really execute this query, let's call it that way, this transformation, until you actually make use of the data, which is what it happens over here. We are actually saying, okay, the result is yet another transformation of the data, and now I'm asking you to transform the results to pandas and to provide that result to the user. So if we were to execute this, as you can see, it's just 3 seconds. In terms of execution, it's super fast compared to the rest of the tools. Actually, this is actually loading everything from scratch. If you have it already, the library is loaded, as you can see, it's taking in about 640 milliseconds to execute. So it's a very vast improvement in terms of the amount of resources, in terms of the time that it takes to play with your data, to explore your data sets. You just basically can continuously play with this. If we were to basically continue, 740 rows, which is then correct, and And we can basically try to load the entire data set for 2009 in pandas. I'm going to spare you the pain of doing this because basically my kernel will blow because it basically runs out of memory. And this is not cool at all. But same thing happens with polars. That will be exactly the same query, just loading every single Parquet file under 2009. But if we were to execute it with Shapelets, now we will be loading, let me see, 5.3 gigabytes of data for exactly the same query. It should really return in about 5 seconds last time I ran this. Let's see. There you are. Well, it's taking a little bit longer than that. It's 9.72. I'm sure if we were to execute it yet again, they will have a similar time and so forth. It really depends on how busy your machine it is, but you know, the big difference here is that obviously we're able to load a massive data set, which accounts for 5.3 gigabytes with the same ease as before, right? And this is quite important because again, this is really helpful when you are transforming data sets and when you are getting things done quickly and moving with high pressure. In terms of performance, we've been running some studies, which I'm showing you down here, just as a brief. We've been running a formal test environment using the New York taxi with data sets of different sizes and with a control set of the different queries. You have the queries here, so you can actually see them. What we are trying to do with each one of those. And this is the results that we get with platforms like Dask, Pandas, Polars, PySpark, and in all cases, almost in all cases, for medium-sized data sets, which corresponds to a month of data, more or less. And then we get pretty good numbers, as you can see from here. Certainly spectacular compared to other frameworks are there. And for other sizes, simply, for large and extra large sizes, what we get is that most of these frameworks won't simply load the data because they just run out of memory. Whilst with those software, as you can see here, PySpark still is in the same range as us. And obviously, for very large data sets, we still need to do a little bit of work. But obviously, we're still showing some numbers, and processing 40 gigabytes in Parquet files is still giving us a good run for the money. So obviously, we're keeping this statistics is about, this is in August, so we certainly will produce all the set of statistics as we move along, because obviously we are keeping changing and improving the system. And obviously our objective is to be one of the most competitive data analytics, data management libraries out there. I'm going to switch briefly just to give you an idea of what this concept of playground is all about. And I'm going to just open a different demo. Let me just clear the results. Let's start clean. Let's restart and clear the output. Start and clear all the outputs. So we go step by step. So in here we are in this demo we are what we like to do is explore this concept of a sandbox and all these relations that we are creating along the line, and what it means to execute them, what it means to delay the execution, or what we do very well, which is to chain all the transformations that you do along the way. So we create a unified execution plan for your data, no matter whether your data is Parquet, CSV files, or a mixture of the two, as we will see in a second, and basically produce the results that you're after. So here, more or less the same. We are creating a sandbox, which is this playground that we have for loading and performing transformations. And in this case, we are just loading 10 gigabytes of data for this demo. So loading the data should be pretty straightforward. As you can see, when we return one of these data sets, in this case, the raw data set loaded from the Parquet files, we get an idea of what are the different types expressed in as NumPy types and SQL types for convenience. And then we can start executing things. Computing, for example, how many rows are in the data set is extremely quick, as you can see, because we execute that query knowing that we are working with Parquet in this case, which means that we can take better use of the statistics that the Parquet files have, and straight away you get a count without having to run a extremely long query. We can get functionality like print schemas, and here we start working with the data. For example, we can select a region of the data, for example, using the limit information, and then create out of this subset a pandas data set. And we do it almost instantaneously. Then and so forth. There is plenty of functions here. I would recommend you to download the library. You can use it for free out of PyPy. I will remind you later on how to get it installed. But the important concept here is that these playgrounds, what allows you, these sandboxes, what allows you to do is to start doing transformations. So, for example, here we are just going to create a new transformation based on the taxes one, where we are going to group by vendor ID and just count how many of those rows are there. So the result is immediate. As you can see, the cell has executed and nothing has done. So only when we go and transform the result and produce the results is when we execute the actual transformation, the actual process to compute the data. So what it means is that, for example, if now we create a new transformation out of the previous one, then we chain all those transformations and we perform supermassively efficient execution plan for it. So in here, what we're doing is just basically on the counts by vendor, just now filter by the vendor ID equal to DDS, which should give us this number, and produce and transform the result to a pandas data set. So off you go, you get the results straight away, and only the computational resources needed to execute this are actually put in place. We can have all sorts of aggregated data. For example, we can have this vendor ID, payment type, what is the average of the fair amount, and then this transformation, we can actually change it. For example, from the aggregated data set, just rename the second column, the third column, which has this strange name because of the name of the function. Let's call it amounts. And now let's filter by using very simply a lambda expression. We say, hey, for every row in the data set, just give me all those that the average of the amount is greater than 10 and show it to pandas. Then we can execute it straight away. And we should get the results. There you are. So all above 10 as expected, and with the column name obviously rename as well. Doing joins is exactly the same type of flavor. I mean, here what I'm going to do is just load a CSV file, which is a super small CSV file, which you can see the contents here. It basically has a code and a long name, and what it's going to be doing is basically matching up the vendor ID with a long name. Okay, so we bring now the CSV file into the playground. So we just load it. And now we're going to do a join. And a join using for comprehensions are simply as 2 4s on a row. So we're going to select the long name from the names data set. We are now going to count how many rows are from the taxes data set. And now what we're going to do is basically join the two together by using the code in the CSV file with the vendor ID on the taxes data set. So here we are mixing CSV files with Parquet files in a single query and in a quite straight manner. So as you can see, executing this query comes back straight away because the only thing that we have done is just basically calculate the shape of the resulting set. Now when we do to pandas and we execute, is when the actually query the query is taking place. And as you can see, the join has happened, and now we have the long name descriptions and so forth. We do have support for things like left joins. We do have support for tons of really clever functions, including geographical functions using the H3 system from Yuba, and all sort of functionality which I invite you to have a peek and have a look. So our clients are using this functionality to work better with the data or in a straightforward manner, something that you can even test, like this for comprehensions, if you have a testing data set outside of your main data centers and the like. And it's super simple to use. We have incorporated very interesting stuff like virtual folders and a virtual file system that allows you to access data sets in your corporation in a secure manner. Perhaps it will be the theme for a different presentation. But I hope you enjoyed this presentation, and you are, in a way interested to give it a go and trigger trigger some activities using our libraries. I know what Jorge is going to say is, how do I install this then?
Okay, thank you so much, Justo. Now it's time for questions. We have some questions here from LinkedIn, and people are asking us if can you tell me what other tools you've used to test your performance?
This performance is based on a very controlled benchmark that happens to be in GitHub. That is I don't know the name on top of my head because it was one of the data scientists that works for us, Carlos, the one that did this work. And but I will be happy to share the details of where the data sets, and especially where all these control queries, which are basically the ones that are executed in every single of these platforms out there, where do they come from, and how is that process works. We can even open up a blog regarding this area.
Okay, great. Another question from YouTube. What would be the first steps to start working with this data ingestion feature? What is the next step? I want to start to use it. What have I have to do?
First things first is just you have our package at PyPy. So if you search for Shapelets platform, just like this, you should find, it will basically install, it will run on Windows and Linux. The Mac build is still not ready, but we have a Docker machine that you could use in that case. And basically runs on any modern version of Python 3.7, 3.8, 9, and 10. The build for 3.11 is still on the go. So this is something that it will be done very, very soon. But if you are in any of those versions, then you can simply do a pip install Shapelets platform and you will be up and running.
Okay, great, fantastic. So I don't know if there is another question. You have more doubts or ideas. If not,
I have a teaser, actually. I have a teaser for everyone. We've been also working pretty hard on data ingestion in real time, and we are working for the next release of the product, which will happen before December, to incorporate data streaming capabilities into the platform. And I'm just going to steal 2 minutes of your time just to show you something that is coming right after the kitchen. And so this is extremely risky to do it in a way, but I'm just going to show you, what we're doing with streaming data. So if you have sensors, if you have working in an industrial environment, in medicine, medical areas, or basically you just have sensors all over the place, then you can start using Shapelets very soon for collecting all that data and storing it in a safe and extremely performant manner, which will connect with this concept of playground. So all the data that we'll be capturing through this mechanism, it will be immediately available for you to play on the using the same tools that I showed you before. So just to give you a hint of what we are producing. So this is basically Shapelets, and this is not public yet. On the now we have a concept of a streamer, which asynchronously is going to accept data either from a stream, either it could be Kafka, it could be, I don't know, RabbitMQ, it could be MQTT, whatever your poison happens to be. And asynchronously will consume the data and push it to a server where it will be stored very, very efficiently. So I'm just going to run the server here locally. There you are. So it's running with 8 threads at the moment. And what I'm going to be doing is actually push a file of IoT, which probably you know if you work with Spark in the past, is the IoT devices.
Share your screen, Justo.
Are you not saying my screen?
No.
I'm still sharing. Hold on a second. Let me stop the sharing and do it again. Okay, can you guys see my screen now?
Yeah.
Okay, sorry about that. So the idea here is that we have this concept of streamer, which is fully asynchronous. I just put the server up and running, which has 8 working threads for data acquisition. And what we're going to be doing is basically pushing this file, which has in about, I don't know, it's a JSON new line delimited JSON file, which has in about close to 200,000 records on it. And we just want to basically push it from the client. So basically we're going to just push all this information down to the system. Here we are counting the time, and we basically wait for the system to stop. And so if we were to run this, let me just hint you how it goes. Boom, it's done. So as you can see, one of the workers has picked up the data, and basically it was made available in 0.196 seconds, really, really quick. And from the client's perspective, the operation completed in 268 milliseconds. So this is extremely huge performance what you're getting to get with this new release that we're preparing of Shapelets. And obviously we will do another demo at some point just to show you how all this whole thing works, how can you connect it to things like Kafka or any of your sources of information, and most importantly, how can you incorporate this data into your analysis very soon. But I'll leave you with this teaser, so I hope you enjoyed the presentation.
Great, fantastic. No more question on internet. So thank you, Justo. Thank you all of you for this time. If you have any other comment or that, we are really, really happy to answer you as soon as possible. Here you have our contact details, and let's keep in touch for the next live streaming. Ciao,
Okay.
bye-bye.
Thank you, bye-bye. Thank you.